So dealing with a Dodge Caliber today, and I think this is mechanic online mechanic tips kind of vehicle. This is his genre of car. So we're gonna see what's wrong with this one and see why it's not starting. It's pretty much rotating. This is a crank no start condition. Yeah, let me hook that battery charger back up. It sounded way better before, but I guess the battery's shot now. So let's see what it's doing now. That's all we got. I'm gonna let this sit for a little bit, let the battery, I do have a regular battery hooked up to it, and I got the jump box hooked up to it, but I digress. We got good voltage from the charger, and it's on start, so I got it on overload. These codes right here are probably related to disconnecting and reconnecting the battery. So I'm gonna ignore these codes because they're like 10 fault codes in the computer system. So let's go ahead and clear all these out. This is the first step of diagnosing. I'm gonna see if there's any correlation with any direct comeback in regards to the crank no start, and just go from there. So this is pretty much the boring part of trying to figure out what part we need to replace, and unfortunately this is where people typically get discouraged and give up. But I would say this is the fun part. So we still have 10 codes here, even though I went ahead and cleared everything out. Let me see if there's any correlation and what are the immediate comebacks. So we got, okay, intake air temp sensor high, fuel level sensor circuit high, engine oil pressure sensor circuit, AC sensor low, anything that, lost vehicle speed message, lost wheel message. So these are all stored active. So yeah, it seemed like we just got a common problem with voltage being missing. Air temp sensor circuit. What I'll do, I'm gonna find the easiest thing and go from there. I did go to these people's houses to make an assessment, but they had a LED test light and some basic stuff. So I know for a fact this does not have injector pulse or crank. So it doesn't have injector pulse or coil pulse. So those two things are missing, but it has power. But I'm gonna go back and recheck that. But I'm definitely gonna go to the easiest thing here, and the intake air temp sensor circuit being high is the fastest thing I can get my hands on. And but if the circuit's high, it's probably disconnected. Fuel level, engine oil pressure sensor, AC sensor circuit, sensor voltage reference circuit here. This is an important one too. Which sensor reference? You know, is the voltage for the 5-volt reference missing? Okay, we got the pedal position sensor, intake runner. Dad did replace that. Let me cut the key in the off position, cut it back on. I'm gonna try erasing it again. Okay, let's see if there's any comebacks. Yep. All right, all that. So let's go under the hood and see what we can do. The intake air temp sensor is going to reside right here. I am in the live data function. What's this right here? I don't know what that is. And we do have a value for the intake air temp. Let me just disconnect this and see if it goes high or not. Yeah, it goes high. So sometimes what'll happen, the computer will give you false information, or there's some delayed gratification, I guess, with some of the check engine light codes, and you will have to go to the generic portion to get accurate information. This can sometimes be a downfall with scan tools, but being that I've been through this before, I'm gonna ignore this. But in the meantime, let's just go. Let me exit out all this, go into the generic portion, and see if these codes are still active. Sometimes you just got to keep it simple. And if there's no codes in this, in the global portion, I'm going to ignore the codes that are in the bidirectional portion and just go on instinct, check for fuel and fire. Marks incomplete. Code 6. No. So ETCs. Alright, so these are still current. Let me try clearing this out. It responds to clearing the codes, but the codes aren't staying cleared. Okay. Alright. Lost wheel distance message. Lost vehicle speed message. Okay. Intake runner circuit stuck open. So intake runner. So this is, I can ignore these two. Let's just go to the next thing. A dad did replace the intake runner circuit. The circuit bank is high, so that means it's probably disconnected. I'm not sure why he replaced that, but there was a code in there. Another thing, I do have all the fuel injectors disconnected. Plug these back in. And then the thing was, it wasn't getting signal from there, so that's how I determined that. I got a couple options to figure out why, but again, the thing is, these aren't getting signal. I only have power, no ground control. I'm going to triple check that again and prove out that there's power there. So this is unfortunately where it's going to get a little complex, but I think I can use a test light, like a light bulb, to determine if this is working. But for the sake of me being by myself and I don't have anybody to crank this vehicle over, then I'm going to have to use an oscilloscope. Before I go any further, I want to keep it simple. I need to check engine speed, and I know for a fact I need to go to the crank sensor. That's just where I'm going to have to go because of the common theme of what I'm dealing with. I have no spark and I have no fuel pulse, so it's just natural, just go straight to it. I'm only 10 minutes into making this assessment here. I'm going to ignore the fuel trim being crazy extreme. Let's just start it up. Yeah, see, there's no engine RPM. It just logically makes sense to go to the crank sensor. There's a possibility the fuel pump's not priming also. I don't hear a fuel pump prime, because if the crank sensor's shot, it's not going to work. I haven't hooked the scope up yet to test anything, but I just need to, I don't want to waste my valuable time checking things that are irrelevant. So let's just go under the car, find the crank position sensor, test voltage, powers and grounds, and see if we have a output. Because if we have powers and grounds and no output, crank sensor is bad. So good news for me, that crank sensor down at the bottom, but the wires I can access are right here. So these are the wires that are coming from the crank sensor. I can work with this. That way I don't have to go at the very bottom and mess around. But let me show you where it's located. Here's the CV axle. It's going to be right behind this shield here. So one thing I can do is just a simple visual inspection. If I can get my hand back right there, just pry that up. It was locked. I can just bring this back up to the top and test the pins, and that way I don't have to pierce anything. So I'm just going to work from the top here. There it goes. I can bring this up. Thanks, Dodge. So I have my connector here for my crank sensor. Here's the PCM. Good news is they're right there with each other, so this is going to be extremely easy. This is going to be C1. I need to be on pin 23. That's going to be our 5-volt reference. I just need to simply match up the yellow and orange wire to correspond with our 5-volt reference output from the computer. And so if I do have continuity, meaning that I can bridge the connection from here to here, then it's not looking good that the computer is going to be shot. If I don't have continuity and the connection's not bridged, and I do have 5-volt reference come out here, we're simply going to be dealing with the broken wire that's located somewhere, and we got to discover that. So let's get this connector off, find our appropriate pin, and do a continuity test. This here. There's our orange wire. Found it. So I got a couple options. I mean, being that I got it isolated, I can just hook it back up and look for a 5-volt reference. But I'm just going to do a continuity test. So once it's determined that it's bridged, my test light's going to make a lot of noise. And that'll be. So let's isolate this wire. We'll hook the computer back up. Key is in on position. See if we have a 5-volt reference. All right, so I just want to let you know, I screwed up. This has continuity from here to here. This has continuity, and it also have a 5-volt reference. And what happened, I didn't have the ignition in the on position. Can you see that right there? Let me see. Yeah, you can see 4.9. So we have a 5-volt reference. I screwed up. I didn't have the key in on position. It's fine. We did an integrity test and it wasn't needed. We got it. So I wish I would have turned the key in the on position and checked this first. I wouldn't have to go through this, but it is what it is. So we're gonna hook this back up, hook the oscilloscope up, and see if we can extract the signal from our crank sensor on the signal side of this connector. Let me locate the signal side, make sure I'm on the appropriate wire, get pierced in, and see if we get a signal. If we don't, then we just got to replace the crank sensor. Based on the wiring diagram, this light blue and brown on the far left is going to be our signal side. So we got the ground in the center and our 5-volt reference on the far right. So we get logged in on here. No need to do a test for the crank sensor because we know on the signal side it had a 5-volt reference, and that was the confirmation to ensure that there's some circuit integrity. This vehicle works off a ground side switch, so we need to see it need to switch from ground and make a square wave. Don't know the pattern, but that's what needs to happen. So I'm going to put this on 1 second per division. That's slow enough for me to start the car and get a capture and see if we have some movement. Logically we shouldn't, but let's see. Alright, so I smell nothing but fuel. Oh yeah, no crank signal. So either two things. The trigger wheel is completely broken and it fell off the face of the earth, and the crank sensor is not picking up that trigger wheel. Or second thing, we just have a bad crank position sensor. Let's pull the crank sensor out, do a visual inspection. It's very accessible, showed you where that was. I'm just gonna take a 10 millimeter, what it look like, pull it out and inspect it and go from there. no. Dang it, man. I done dropped my stuff. Dang it, man. Darn it. Here's the crank sensor. Let me see what kind of mess I made. All right, let's see if we can change the state by putting something that's magnetized. And it's not. It's getting a little closer than normal. All right, let's pull it out. I got a test light. It's grounded. Let's see if it'll actually, oh no. See if it'll prime the fuel system, because since it's ground side switch. Yeah. Yep. You hear it. Oh shit. Yeah. Yeah, the injectors are pulsating. Let me turn the fan off. I think I'm on the appropriate side, and the signal is going to be here. So let's give it ground and see if it changes state. And it's not. Maybe what happens, it drops off this voltage reference wire or something. Yeah. Well, the 5-volt reference, it gets dropped off. So I guess that's the back feed, that there's some sort of transitioning going on. So the signal side, yeah, that can work. But what looks like, if I ground out the 5-volt reference, this is what works the injectors, prime the fuel pump. The signal just reinforces the idea that the crank sensor is working, and I guess the 5-volt reference got to be pulled down. Learned something new, so I thought we had to go on the signal side. No big deal. Let's put a new crank sensor in it. Once we put a new one in there, it's going to work. Being that this crank sensor isn't generating a square wave as it should, which is an indication that the sensor is just simply defective. Let me go grab a crank sensor and we'll pop one in there and get this car back running. So next day, wound up going to O'Reilly's and getting a new crank position sensor. If you know, I frequently patronize that company. We have a bittersweet relationship. It's a standard motor product. Strangely, this cost more than the Delphi and was a little bit more expensive. Don't understand why. PC684 is a part number if you care. Let's move on. So the old one is still hooked up to the oscilloscope. Simply put, I think this is one of those occasions where we can just do a resistance value test and compare a new working one with the old one. And before I do, I'm just going to do the waving test one more time and then swap it with the new one, do a waving test, see that it works, and then we'll just do a resistance value test. So here's the old one. Oscilloscope is still hooked up on the same time base. So I can enhance that. We have no functionality with the old one. Take this out, pop in the new one. This is old Swaptronics. Now we have square wave. We have the ability to work like it's supposed to. So this one's gonna work. Let's do a quick resistance value test for this component and see what the numbers are. I typically don't like to do ohm tests because they're very unreliable, but being that this is blatantly shorted out or have failed, let's just see what it shows. I think we are going, there we go. All right, this one's making 32 ohms. So we're on the ground and the 5-volt reference, 32 ohms with the old one. And here's the new one. Making 514k ohms. Now I'm gonna be honest, typically switching circuits I see around 500, 600k ohms. So that's typically what I'll expect. I don't test these a whole lot. or have to deal with transitioning circuits or driver circuits a lot on a regular basis, but that is a common theme that I have seen, whether it be for injector drivers and coil drivers. Anyway, we got a value. Let's pop the new one back in there and see if it actually hits and start up. We know it's bad. We're 100%. We didn't throw any parts at it. The owner wound up putting a fuel pump in there with no avail. We know for 100% that it's defective. We threw $0 in it. We only just bought this crank sensor. All right, we're gonna capture a starting condition with everything working as it's supposed to. If it don't start up, then we got something else wrong. But we know we were missing a crank signal. It was a very well thought out crapshoot if it don't start up. But let's see what happens. Sounds horrible, but it starts up. One thing, the owner, he wound up putting a crap ton of starting fluid inside of there, so it's got to burn all that stuff off. And he did, I don't know if he put new plugs in it or not, can't remember. So here's our pattern. It looks beautiful, absolutely beautiful. It don't get no better than this right here, how this pattern looks. It needs to burn that starter fluid off, and that'll be it. We already got a pattern. We got a perfect capture. Take a screenshot of that for future reference. No, come on. There we go. And let's get it running. It should clear up once all that brake. There we go. It's gonna clear up. So we're probably, usually when it misfires like that, sometimes you can have throttle body problems. That's why I was like waiting for it to clear up, to burn off all that starter fluid that was put in here. So we're good now. I'm gonna do a couple snap throttles and see how it responds. This battery should be okay. Find out. Take my charger off. Back in the car, I'm gonna get logged in the vehicle's computer. I'm just gonna go to the generic portion, wherever I'm closest to. Yeah, I'm in the generic portion. I'm gonna clear those codes out and see if they immediately come back. Snap throttle. Oh yeah, let's clear these out. Oh gosh, it shut down. Uh-oh. It probably still had a crap ton of starting fluid in there and it can't regulate properly. Pending intake runner. Is this connected or not? Oh gosh. I probably need to do like an idle relearn or something. I don't know what's up with this here. This is the problem we get. She changed the fuel pump and the intake runner. I don't know why. I don't know. Let me see if the check engine light actually comes on. Sometimes I can't trust my scan tool. Set it down. 184 miles on this vehicle. If it stays on, then the circuit, yeah, that runner may be completely disconnected, or he probably put a bad one on it. Let me locate it and see if it's connected. It wasn't connected down here. This way. So that'll fix that code. If I can get it in there like so. Alright. Stay in there. Let's try this again, since it was blatant. Satisfy the conditions. Learned that from programming the key yesterday, well 2 days ago in a Cadillac. I need to follow instructions. Okay, no codes. Let's see how it accepts a snap throttle. Oh yeah, perfect. Hey man, this car is fixed. What else is there to say? This part, this was the problem. I don't know why the owner put a fuel pump in there, and I think that's something I will probably never fully understand why. Hopefully, you know, we can all take a lesson from this. Is just why important, why we diagnose things. And then trust me, I'm not 100%, but as long as we can stay on topic, if we isolate what we're dealing with, stay on topic with what the car's unsatisfied conditions are, we can definitely feel a little bit more secure about shooting from the hip. You know, I wouldn't have blamed the guy if he would have been like, okay, let's least to greatest, let's put a crank sensor in based on not getting injector pulse, fuel pulse, throw a part at it, throw a crank sensor at it. It's common. But a fuel pump, I don't want to get it. The intake runner, I don't get it. But this is, we got to stay on topic. What are we not getting? What needs to happen? What is an unsatisfied condition? I cleared the code, immediate comeback. Even though I did not know the definitions of some of those, I did not. I didn't like, all right, let's just do the topical assessment. No fuel pulse, no crank, no ignition pulse. Well, let's check the crank sensor. Pull that out, check powers, grounds. I overlooked it. You see I make mistakes. Didn't have the key in on position. It happens. I actually had power, I had ground. I did not have a signal. And it would have been wise for me to load test the powers and grounds. But being that, you know, I kind of went along with my meter, my Power Pro 4, I trust it. I trust the judgment of it, and they were adequate powers and grounds. Tested the sensor with the oscilloscope, didn't have any output. Now, I'm not going to remember the ohm value of this component because I typically don't check resistance value when a component is dead. It's just dead in the water, just like this one here. The oscilloscope kind of reinforces the idea of not having to use the ohm to test the component. You know, so that's just old diagnostic procedures, just doing the ohm value, and it's just so ineffective. But we got to the problem, isolated the issue, pulled the crank sensor again, did the values, put it on the oscilloscope, saw no pattern, tried, you know, forcing the issue, tapping on the sensor, nothing, and just totally justified in replacing the crank sensor. Got a new one in there, worked out perfect. Wound up getting a pattern. We could do those same tests, and the oscilloscope reflected a pattern, so the signal side was actually capable of retrieving the signal now with the new sensor. As far as like any key takeaways, just if you're dealing with wiring, don't ever be intimidated. And just like from my last video with the Cadillac, from this video, if we understand what we are dealing with, we can better address the situation. So don't allow the red herrings to get you distracted from resolving what is ultimately whatever the point of contention is. So we're trying to fix a issue. I'm not going to check tire pressure. I need to figure out why we got what we got going on. You know, even though the owner tried replacing some things, but it cost them money. Well, working slow in this particular case would definitely allow us to work a lot faster and effective. We didn't have any injector pulse. We didn't have any ignition pulse. What's the common thing? You know, we know that just general knowledge right now. If you don't know now, you know. We need the crank position sensor. That is such an integral sensor. That without that 360-degree rotational acknowledgement, the PCM don't know what to do. It can work without a cam position sensor, but it needs to know that 360-degree rotation. It can make a determination of how to work other components, but we need to know that. We need to know it. So stay on topic. And I hate this word is just so watered down. I'm not gonna say educate yourself because what we feel isn't always universal. So we need to be familiar with what we're dealing with on a universal level. It's not related to oil viscosities or anything. We need to know how these components work and what they do. This pretty much just receives a signal from a rotating component. It's a wheel speed sensor, essentially. It's monitoring the crank position, the speed of that. It takes in that vital information, sends it to the PCM. The PCM makes the determination of how to alter the timing and the injector pulse. It needs this. So, I mean, just clear the codes, see what are the immediate comebacks, and go to the easiest thing, you know, is if it's correlated with the complaint. Car's not starting, I'm not going to care about the intake runner. You know, there were some wheel speed codes in there, probably for the engine speed, but I didn't, you know, this is just because of my experience. I didn't look that up, but I had general knowledge of what I need to go to. And based off the general knowledge of testing these components, I was able to narrow down and get to a resolution, which was replacing this crank sensor. Hopefully all that makes sense, and it will help somebody else when it comes to making some sort of assessment with the no crank, no start condition. Trust me, it could be a plethora of things. It's just not one thing that it can be. We could have been dealing with a broken wire, but you can see, like in my previous video with the Cadillac, I was able to track down that wire and get it resolved. But we have to have information. We have to have factory service information. I pay for Identifix on a monthly basis, and it gives me the ability to, with their best of ability, because sometimes these wiring diagrams lie, to point me in a direction. But I have to understand what I'm dealing with. So stay on topic. But if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed, how to original my work. See you next one.